Students, in this video, we're going to be looking at section 12-2A, problems 20 and 21. We'll be looking at these problems using GeoGebra. So I'm going to share my GeoGebra screen. So problem 20 says construct any convex kite. Then construct a second convex kite that is not congruent to the first, but whose sides are congruent to the corresponding sides of the first kite. So you can see the kite that I have here, and pretty close to a kite. I was attempting to get all of my sides the same. Now in a kite, you don't have to have all four sides the same, but I wanted to have an isosceles triangle on both sides. So my sides are around 1.9. And now I need to come up with another kite that is not congruent to the first, but whose sides are congruent. So what I want to do is take this diagonal and I'm going to just shorten it slightly. And then drag and get side lengths that are 1.9 again, close as I can get it. But you can tell it's not congruent to the first kite. Not all the angles are the same. So there, my drawing came out pretty close. So you get the idea that using two isosceles triangles, it can help you to solve that problem. Okay, now that was 20. On number 21, what type of figure is formed by joining the midpoints of a rectangle? Justify your answer. So I'm going to draw a rectangle here, assuming that we have 90-degree angles because a rectangle has opposite sides the same length and all of the angles are 90 degrees. The other thing that we're told is that we're supposed to connect the midpoints of the sides here. There's all of our 90-degree angles. Now we'll use our midpoint tool to get the midpoints of the sides. And then we'll use our segment tool to connect those points. And we need to say what figure you would have on the interior given certain things that are congruent. So they tell us in the problem that we've got these two lengths are the same because E is at the midpoint. And likewise, since L is at the midpoint, we've got these two lengths, they're the same. But opposite sides of rectangles are the same length, and we've got a midpoint on the opposite side as well. So we also have these two the same. And then across from segment AD, we have some sides that are the same as AE and AD because of the midpoint as well. So now we can look for congruent triangles. And I see by side angle side, I have 4 congruent triangles here. Side angle side, side angle side. And because corresponding parts of congruent triangles are congruent, we can also say that the hypotenuse on all 4 of these right triangles is the same. And when you have a quadrilateral with all 4 sides the same length, you have a rhombus. So we have just proved that we have a rhombus. Okay, the steps to proving this, again, were number 1, to show that we had congruent triangles by side angle side. And then number 2, by corresponding parts of congruent triangles are congruent, the hypotenuses of all of those triangles are the same, and therefore we have a rhombus.